Hi, I'm Sarah Kaufman, and I would like to introduce the ECLAIR team final presentation. ECLAIR is an acronym for Engineering, Chemical Labs, and Inventory Regulator System. This is our ECLAIR 3 team. Also, special thanks to our sponsor, Jonathan Klein. Project Overview. The purpose of the ECLAIR system is to allow users to manage chemical supply information in the ASU laboratories. This information is important in complying with government safety regulations. There is a need for this, as currently lab administrators pass around Excel documents to track chemicals. Staff do not have real-time inventory access or electronic location tracking of chemicals. This problem must be solved to lessen logistical overhead in lab management.
Hi, I'm Nick Martinez. I'm working on the backend team on the ECLAIR, and I'm going to go over the project requirements. So the first requirement of this Capstone project is that we need to develop a web application with which ASU personnel can access to view and update chemical inventory information. And as Sarah mentioned, this is basically going to be used to expedite the process and make it more secure and more convenient for all of the ASU faculty and lab managers. The second requirement is to store the chemical data and provide the necessary application logic for viewing and manipulating the chemical inventory information. So this really speaks to the back-end side of the project and really having the necessary data access and also just data flow and data logic to basically run the application and make it efficient and make it meet the needs of the users. The third requirement is to provide a useful and intuitive user interface that users can navigate through to perform their actions. So we really had a lot of user stories that we had to kind of influence the user design and really made sure that the project was always coming from the user's perspective and it was always designed with that in mind. And finally, the fourth requirement is to host the project on ASU provisioned server, therefore avoiding the reliance on another hosting platform. And so long as the user is using the ASU network, they should be able to access the web application. And this requirement was really taken care of in the first semester when we got in contact with UTO and ASU personnel. So overall, these are the four main project requirements. Again, just to review, they are the first one outlines the basic project necessities. The second one outlines the application logic and data transformation and data flow. The third one outlining the user interface and how it should be intuitive and be able to access and view. And last one just being hosted on ASU networks rather than a third party that would cost more for us. So those were the requirements.
My name is Everhart, and I'm going to go and talk a little bit about higher level overview and then sort of like the architecture of how we combine it. So the application, of course, enters from the login because users will have to be identified and be given certain permissions for what they can use, update, and view. And so upon authentication, it would bring them into the home screen, which gives you the ability to navigate or use some quick task-based links. Some examples of those quick actions could be, updating chemical quantity, moving the inventory around. You could view fire control zone information. And so you would have access to these quick actions, but then you would also have this navigation drawer, which would give you different scopes to view information. The three main scopes that we have to include. First, we need scope by lab, which can tell us what specific chemicals are contained in a specific lab, and then you can modify them by adding, removing quantities. You can view the fire control information of that specific lab. Another scope of the information that's really important is to manage it by the entire school. So you can see the entire cumulative inventory information of the school, and just by looking at it, you can see summaries of fire control zones. You can easily find your way to different labs that are contained within the school. And then another scope of information that we have is the building overview. So in the same way of the schools, we can get sort of summary information, fire control zone reporting, and then you can even get down into the specifics of areas within the buildings. So let's talk a little bit about the technology that we used. So to begin, we used React on the front end. In the back end, we used Golang to set up the listener for API calls. We used it to make the connection to our back-end SQL database. We also used some Golang code to manage bulk updates to the back-end database. and keep changes to the schema of the database consistent between users. We had a server partitioned to us by ASU, which we hosted our code on, so we have a definite URL which is always running that we can call for our API calls. We used Git to upload our code and changes on our home machines, and then we could pull them on the Apache server later, so we didn't have to use like a Vim editor to edit our code on the Apache server. On terms of just being able to keep us synchronized, something that was super useful for us was using a Trello board. We used a Trello board to track our progress week to week to week to week, and so we would constantly have introspection into what other members of our team were working on. It kept us accountable because every single week we would have to report, all right, this is what I got done, this is my blockers, this is the situation, and people would be able to lend their help accordingly. We used Slack to keep us updated on, we had different groups for our front end and back end, so we could keep contact within ourselves, and then even coordinate between teams and get an idea of where we all were in respect to each other. And we also used Skype. We used it to verbally communicate when it got more difficult to meet on campus when things got really, really busy. So communication was really, really crucial for our team.
Hello, my name is Michael Puskas, and I'm going to talk about the design decisions that we made and why we made them. First off, I wanted to lead with the permissions table. So a lot of the design decisions that we made were focused around the types of users that are going to interact with this thing and how we can get people that have certain goals to be able to quickly accomplish those goals. So first level we have is the lab level. So this would be for someone working in the lab. Their goals are focused around using chemicals, adding chemicals in, viewing inventory, all this type of inventory management stuff that would come with being in the lab and trying to conduct their experiments. So from the lab level, you can do all the inventory management. You can also quickly see the fire control zone status, and this would be for a secondary goal, which is a manager wants to look into a specific lab and see if there's any issues with the amount of chemical that is in that lab. So from this view, you can do all that. From the school's view, so this would be for someone doing reporting on the school level. They can quickly see all of the labs that belong to a school. They can either get a cumulative inventory from all those labs, or they can see the fire control zone information for all those labs at the same time. Kind of gives them a dashboard so that they can quickly determine if there's anything that they need to do in relation to that school. So on to buildings. So buildings would be for either the overall manager of this entire system or for someone that's keeping track of that specific building. And from the building's view, the main important thing is with all the different labs that belong to different schools in this building, is there any issue? And if so, being able to drill down and figure out where exactly that issue is and who to contact from there. So the entire goal of this is to give people an easy way to figure out where the issues are and what their next step is. Last one is control zones. With control zones, being able to, once you identify an issue, figure out what exactly needs to be done in order to remedy it.
Hi, my name is Lloyd Allen, and I'll be talking about the results of our project. So, as stated before, the ECLAIR project aimed to improve the tracking of the ASU chemical lab inventories and determine compliance with fire control zone regulations. In order to achieve this, we had 3 deliverables. We implemented a backend with database to provide real-time inventories. We created user-friendly website for users to search chemicals, their unique chemical numbers, fire control zones, and the previous information, the schools and labs and whatnot. We also provided documentation for future users and developers. The following few slides are just a few examples of what we did. In the back end, again, we implemented a database. You can see some of the code that we provided. For the front end, you can see some of the code that's actually on the server right now. And for the documentation, you can see some of the stuff we provided. We provided an updated schema. We provided background info, such as the MAC tables for calculating the maximum allowable quantities. And we provided implementation details, such as a description of the tables.
Hello, my name is Ahmed Alagili, and I'll be talking about the lessons we learned going through this project. First of all, we inherited work from a previous group, and so we had to examine and see what work should we use in our current project and what should we just build from our own. We concluded that we should use our own technology, but we used some of the information that the previous group used, like some of the structures that they used. We also spent a lot of time expanding our domain knowledge. We learned about a lot of different things that we did not experience before, and that took a lot of time. And in the future, we would look at that as a cost, a time cost. For the prototyping, we met with an ASU lab manager and took his feedback into consideration when we built the platform. We also met with our sponsor almost bi-weekly, and we took his feedback, and also we made sure that the expectations that he set were met also and realistic. For the ASU server, we learned from our previous group that how long and how tedious the process of acquiring one was, and so we made sure to start the process early for the first semester, and we were able to get permission to use the server early on. For the future, we'd like to implement authentication, and there are many improvements that we could make for the project. In conclusion, we think we've met most of the deliverables that we set out when we started this project. As I mentioned before, we still have things that we would like to improve or for future groups, and that's why we're documenting most of the stuff we're doing. Here some of the deliverables are we've created a web application that works on both mobile and desktop. We use the ASU server to host a database that has most of our content. At the end, we'd like to make a special thanks to our ASU sponsor, Professor Jonathan Klein, for his outstanding support, feedback, and mentorship. Thank you.